Hello everyone, so we are back with Leetcode daily challenge. In today's problem we need to convert a array into a 2D array with some conditions. So you are given with a nums array which will contain some integers and there might be some duplicates, and we need to construct a 2D array from the numbers inside that number array. The conditions are given below, like first the 2D array should contain only the elements from the nums array, right? And then the second condition is that the 2D array contains distinct integers, like each row of the 2D array should contain distinct integers. The third condition is that the number of rows should be minimal in our answer 2D array. So also one thing to notice is that the numbers of element in each row can be different. So let us try to understand this question a bit more clear from the example given below. So for example, here the nums array is given and the output is like that. So let us try to understand the example. So here 1 3 4 1 2 3 1 1 3 4 1 2 3 1. So these are the nums number inside the nums array. Now how can we create a 2D array where the number of rows should be minimal. Second, each row should contain only unique numbers. So first of all, what we will do, we will try to find out all the unique numbers from this array. So the numbers are 1 3 4 2, right? So these are the unique numbers. So 1 occurs like 3 times, 3 occurs 2 times, 4 occurs 1 time, and 2 occurs 1 time, right? So what we will do, initially we will to minimize the number of rows, what we have to do, we have to store all the unique numbers at first in the first row. Then in the second row, what we will do, we will again iterate over these numbers and try to find which occurs again, like for the second time. So here 1 3 4 2, what we are left with 1 3 4 2, we are left with 1 3, and in the another case this is the first, this is the second, and this is the third, we will left with 1 because 1 occurs 1 2 3 times, right? And 3 occurs 2 times. So in the next row, what we will do, we have to add 1 and 3, and in the third row what we have to do, we have to store 1, because the condition is that we need to store unique elements in a row. So if we try to store this 1 in this first row, then it will violate that condition, right? So this is the approach, like we have to first store all the unique element, then in the second iteration we have to store the next phase of unique elements, and in the third iteration we have to store the next phase of unique element. So let us try to figure out a solution. So let us first think about a brute force approach. So when we think about a brute force approach, it is clearly mentioned that we need to keep a unique element in each row. So for that, what we have to do, we have to keep a track of number of occurrence of the elements, right? So what we can do, we have a hash map solution, and we will store the occurrence of each element in that hash map. For example, here 1 occurs 3 times, 3 occurs 2 times, then 4 occurs 1 time, and 2 occurs 1 time. So what we will do, we will have a loop and iterate over the hash map, and in the first row, like this is the first row of the 2D array, we will store the all the unique elements, like here 1 3 4 will be 4 and 2 will be there, and this 1 will be changed to 0, this will be changed to 0 in decrement by 1, and this 2. In the next phase, in the next row, what we will add, we will add 1 and 3, and it will change to 1, it will change to 0, and in the next row what we will add only 1 because it have 1 occurrence left. So this is the brute force approach. Let us try to figure out what is the time complexity and space complexity, since we will iterate over the number of element each time and into the occurrence. So it will be like n into m, where n is the number of elements and m is the peak occurrence, or maximum occurrence. And what will be the space complexity? We have to keep a hash map, so the hash map will have a space complexity of like n is number of element into m for the number of occurrence of that element, right. So this is not a optimal solution, we try to figure out a optimal way. So let us try to move forward with the optimal approach. So let us try to understand the example a bit clear. What we have to do, we have to just keep on mind that our unique element, like the if a element is repeating, then that number should be in the next row. So for example, if we have this example, if we take this example only, so what we will do 1 3 4 then 1 2 3 1, right, 1 2 3 1. Now what we will do, we will sort this number array, right, and after sorting what we will get 1 1 1 occurring 3 times, then we will get 2, then we will get 3, we will get 4. The main reason for sorting this array, it is to keep same numbers together. The reason is to keep the same number together. Now why we are keeping the same number together, what we will do after that, we will have a iteration over this sorted array, and we will check, like we will have a check whether the current number equals to last or not. If it is not equals to last, let us take the condition of it is not equals to last. What we will do, we will add that current number to the first index, right, we will add that current index to our answer, like we will have answer array, and we will just push back to the first index of that vector, that number cur, right. And what we will do, we will then increment the like we will have another index, like index variable to store the index. I am telling why we will store the index. It will initially set to 0, and we will have a variable called last, which we will set to 0 because the numbers will start from 1, right. So if it is not equals to the last number, then we will just simply push that element to the first row. If it is equals to last element, like we have already come up, like for example here 1 is added to the first row, right, and now we are in the second row. So now we are in the second occurrence of 1. Now what we will do, we will if it is equals to last, what we will do, we will check like we will try to add that 1 into the another row, because in the first row already 1 is already inserted. So we will try to add that 1 into the second row, like it will be added to the this row. And when we move forward with this third occurrence, then we have to add that 1 into the third row. So what we will do, we will iterate over this nums array. We try to find out the each occurrence. If it is equals to the last number, we try to add that number into the next row. So what we will do, in simpler term, what we will do here, we will add cur to next row. Now to do this thing, what we need to do, we need to keep some things in mind. First thing is that the size of the array is not static, like we cannot fix the size of the array, right. So what we have to dynamically resize the vector, the answer vector. So here we have to have a check, like if the size is less than current index, like in each time when we have a cur equals to last, we will increment the index, like in which index we need to keep the next element. If the size is less than index plus 1, because index are 0 based and size are 1 based, if it is less than index plus 1, then we have to resize the array. We have to resize the array and we have to create a new row. Here we have to create a new row, and after resizing we will put the element into the index, like the index we have storing into the index of that vector. I hope it is clear. So let us try to code this solution in Leetcode and try to like understand a bit more clear. It will be more clear when you see the code. So we will move forward with Leetcode. Yeah. So what we will do, We will first have an answer array, vector of vector. Let us try to resize the window so it is clear. Yeah, so we have a vector of int of answer, and initially we will set the size to 1 because at least it will have a 1 row, right? Now what we will do, as I said, we will sort the nums array, nums dot begin, and then nums dot end. So after sorting the array, what we will do, we will take two variables, one to store the last number. We will initially set it to 0 because all the numbers will start from 1 as in given below here, right? And then we will have an index which we will set to 0 initially, right? Now what we will do, we will iterate for each number in the nums array. For int I equals to 0, I less than nums dot size I plus plus. Now what we will do, we will have a check whether the last number is whether the current number is equals to last or not. If the current number, if nums of I is not equals to last, so in the first case what we will do, we will set the last two nums of I because current number will be set to last, and then we will set the index to 0 because the index will be updated in the another case, and we will then store this current element in the first row. So index will be 0, so it will be by default first row, push back nums of I, right? And after storing that, we will increment the index so that it will for the next iteration the index will be pointing to the next row for the another element. Else, like if it is equals to the last element, if the current element is equals to the last element, then we will already have the index, like we will already have the index where we need to put that element in that ind variable, index variable. So before that, what we need to do, we need to check the size, whether the our current answer array size is greater than the index or not. So if we have a check answer dot size is if it is less than equals to, if it is less than index plus 1, because index are 0 based, if it is less than index plus 1, what we will do, we will resize the answer array, resize the answer array to index plus 1, and then what we will do, we can now put the current element into the index because it is a valid index. Earlier it was not a valid index because the size was not to that index, right? So we will put answer index dot push back current element nums of I, and we will increment the index, right? So after doing all this, what we will do, we will just return the answer. Yeah, let us try to run this code. Submit. Yeah, it works fine. So I hope it is clear. Let us try to figure out what is the space and time complexity for the given solution. So what we are doing, we are iterating over the sort array, right? So the sorting algorithm will take off n log n, and the rest we are just iterating, so it is a order of n. So here the major factor is this n log n, so the time complexity will be n log n, and for the space complexity we are not using any extra space, we are just using some variables, and the answer array is a part of answer, so it will not count, the 2D array will be not count as a space, so the space complexity is order of 1. So this is a very much optimal solution. I hope it is clear. Thank you for watching.